student. In the last class, we have discussed about orbit, shell, and structure of their orbits, right? So in the today's class, I said I will explain about some wavelength, frequency, speed of light, right? And then later amplitude, intensity. Amplitude or intensity is nothing but same. So after having these definitions, I will give some examples or problems to solve, and then later we will see the next part of this chapter, right? So today we will start with the speed of light, right? What is speed of light? So speed of light, when we can imagine in with respect to the distance traveled, right? That's all. So we will we will be having a standard timing, that means per unit time. When we can say, you can take as a one unit as a standard unit. 1 minute you can say, 1 second you can say, one fraction second you can say, right? So in 1 second or a 1 unit time, per unit time, the distance traveled by the light is nothing but, so what I will say generally, right? I will just I want to see the speed of light means. So what I will do, I will take a unit time, right? So 1 second you can say, just for example. So in 1 second, how much area does that light is covering, right? That is nothing but the speed of light, right? Definition, you can say the distance traveled by, so the distance traveled by, the distance traveled by a wave. So light will be always travel in the form of wave, by traveled by a wave per unit time. Per unit time is called speed of light, right? So the distance traveled by wave per unit time is nothing but what? Speed of light. To calculate the speed of light, here the formulas are very important. Remember these. To calculate the speed of light, we have a formula, that is the mathematical expression. So C is equal to V lambda, when we can say, right? V lambda, right? V lambda. So here, where C is speed of light. What is the speed of light? C is speed of light, which is 3 into 10 to the power 8. 3 into 10 to the power 8 meter per second, right? You already know in the lower classes also, you will be having this. I think you have heard about this, right? And next, V is nothing but frequency. V is frequency. And lambda is nothing but wavelength, right? Lambda is nothing but what? Wavelength. Remember this, don't forget. To calculate the speed up, why? Because in your competitive as well as here and there in the alternative years, I mean in the previous years alternative, they have asked about to calculate about the speed of light. To calculate the speed of light, we must and should know about this. C is equal to V lambda, right? So I will directly give you one example on this, right? So that you can understand, or else we will do one thing. After having all these definitions, you just remember these things. Very simple type of mathematical expressions. So you just remember these. Later, after having all those things, we will be having all the problematic part once only, right? So this is about the speed of light. That is nothing but the light will always travel in the form of wave, right? Don't forget it. In physics, you might be having more detailed study about all these, but we are having just very little bit introduction about these. Amplitude or intensity. Amplitude or intensity, right? So what is amplitude and the height of, see, before going to the definition, wave is traveling like this means, I mean light is traveling in the wave form means, say for example, if it is a surface, if it is a surface of a water, you can say imaginary line, right? So now, what is the thing is, the light is traveling in the wave form means the wave will be like this. That means it produces crests and troughs. Right? Very important. So crest is nothing but depth. That means crest is nothing but depth. Right? So this is nothing but the crest. And trough is nothing but the height. Right? From the imaginary line or from the surface. Say for example, if it is a surface of water, right? If it is a surface of a water, down over here there is a water, and above there is an atmosphere. So now, if the light is traveling means, if it is coming like this, that means in waveform only it is traveling. That means once it will come down and then again it will go up like this. That means it will form a round structure. If I break half of this and half of this in the, and if I join it, these two, imagine this half, that means upper half and lower half. If I imagine, I mean join these, then it will make a circle, right? So like this, that means the thing that the light will always travel in a what waveform. So in waveform we have crest as well as the trough. So crest is nothing but depth and trough is nothing but height. Right? Trough, we know trough, that means height, and the crest is nothing but the depth. The height, sorry, I have just this is not a crest, it is trough. Sorry, extremely very sorry. Trough, and this is crest, height, crest. So height of the crest and depth of the trough. Sorry, actually extremely very sorry. So depth of the trough and height of the crest is nothing but what? Amplitude or intensity. So now when the amplitude or intensity increases means, if the depth of the trough is more and the height of the crest is more, that means if they able to form a big height and like this, if it is more like this, then the intensity one we can say it is more or amplitude is more. So that means amplitude or intensity is nothing but height of crest and depth of the trough is nothing but what? Amplitude or a intensity, right? Next, wavelength. Next is wavelength. So make a correction. I have just did a small mistake. That means about crest and trough. Right? It happens. And next is wavelength. So these are very important for us, right? And wavelength is represented by lambda, right? So wavelength. These points are very important for us. The distance between two successive crest or trough. The distance between two successive crest or trough. Two successive crest or trough is nothing but what? Wavelength, right? See, again we will draw an imaginary line first, and then we will see about the crest and trough, right? So now if I start from here, then it will be always like this, right? So now so the height of crest, so this becomes crest, and again these are the crests, and these are the troughs, we can say trough. So that means the distance between two successive, you can take two troughs or two crests, right? The distance between these two is nothing but what? A wavelength. Very simple. So the distance between two successive, you can take any. If I consider it as a trough, then the distance between these two troughs, the distance between successive two successive crest or trough, that means two successive, you can say, you can add these before successive, two successive crest or trough is nothing but what? Wavelength. Understood? And the SI unit of wavelength is SI unit of wavelength is what? Angstrom. Already you have studied, right? So SI unit of wavelength is always angstrom. I repeat, the distance between two successive crest or trough is nothing but what? Wavelength, right? Remember this point. And then frequency. So we will move towards now with the frequency. Frequency, which is denoted by B, right? Frequency is denoted by letter V. So now the number of wave pass a point, the number of wave pass a point, the number of wave pass a point in 1 second of time, in 1 second of time, in 1 second of time is called a frequency, is called frequency, right? The number of wave, say for example, again we will take a imaginary line, a small imaginary line. So now what I will do is, so definitely the light always travel in a waveform like this. So that means its speed also we know, right? 3 into 10 to the power 8 meter per second. So now say for example, I will consider any one point in this imaginary line or else the waveform. That means if I say example as I am keeping a eye on this point, right? Very simple, very simple. I have just considered a one point. I have picked one point in the imaginary line, and now what is my duty is to check how many number of waves are passing in how much time? 1 second time. That is nothing but what? Frequency. Very simple. So that means the number of waves, that means the number of waves pass a point, a particular point, you can take any particular point, pass a point in 1 second, and the duration of time is just a fraction 1 second, right? So in 1 second, how many number of waves are passing this particular point is nothing but what? Frequency. And the frequency SI unit is hertz. SI unit is hertz. This will be represented like this, h to the base z. Right? So dear student, this is all about today's class. In the next class, we will see the next part of this. Right? Thank you.